day, everyone. So today we are going to tackle about scientific revolution in modern ages. But in this lesson, we are just going to focus onto the two important person. So the first person is Tycho Brahe, life and also his contribution, and the second person that we are going to tackle in this lesson is Johannes Kepler's life and also his contribution. But before we start our lesson, we have our three objectives. So the first objective is we are going to explore the backgrounds and early influences of Tycho Brahe and Johannes Kepler. Our second objective is to understand Tycho Brahe's contribution in precise astronomical observations and Kepler's laws of planetary motion. And the last objective is we are going to examine their collaboration and the impact of their work on the history of astronomy. So now, let's go to Tycho Ottesen Brahe's life.
Welcome to the life of Tycho Ottesen Brahe. So Tycho Ottesen Brahe was often referred to as Tycho. He was born in December 14, 1546 in Der Lagmanor in Natstorp, Danish, a region in Scania, which is now called Sweden. His father was Otte Brahe and his mother was Beat Bill. So Otte Brahe was a member of the royal court and his mother was an important aristocrat. This couple had 12 children together and Tycho was their second child. In his second year of life, Tycho was kidnapped by his own uncle and own aunt. This couple were Georgian Brahe and Inger Oaks. This couple were childless and when Tycho's parents agreed, they made Tycho as their own child, their own heir. In 1560, Tycho Brahe witnessed a solar eclipse which fascinates him because before it happens, many astronomers predicted that it would appear. So this took Brahe's interest in astronomy as well. The Brahe family were all powerful and militaristic. So Tycho Brahe was supposed to be a warrior, but he didn't become a warrior because his foster mother, Inger Oaks, came from an academic family. So Tycho received an academic education instead. So Tycho Brahe, as the heir of his uncle, was supposed to inherit all of his adopted parents' wealth. But before his adopted father could process his paper of inheritance, he died of pneumonia after falling into water. This left Tycho with nothing but a part of his biological parents' wealth after Otte Brahe died. When Tycho was 19, he arrived back at Germany where he has gotten into an argument with another Danish student like him. The cause of the argument was unknown, but there was some claim that they were fighting about who's the better mathematician. So, this led to the two students dueling with sword and causing Tycho to lose his front nose and having a permanent scar on his forehead. At the age of 25, Tycho took a commoner woman, Kirsten Hansen, as his wife. And at that time, it was illegal for them to marry the ordinary way unless they lived for 3 years, which they did. So, these two had 8 children together, 6 of those who survived into adulthood. Unfortunately, these children cannot inherit the nobility status of Tycho Brahe, but that was only before his exile from Denmark, where they lived at the court of the Holy Roman Emperor Rudolf II. There, they were treated as nobles. So Tycho Brahe was a known drinker, and he had a plenty of drinks at the banquet held in Prague. At that time, when he wants to urinate, he cannot excuse himself to the banquet because that would be considered disrespectful. He held it for too long, his bladder ruptured. This causes death on October 24, 1601 at the age of 54. However, Tycho Brahe's death had so many speculations, such as scientists finding mercury on his remains, claiming that he was poisoned. Separately, some tests revealed that his silver prosthetic nose was actually made out of brass, which is a harmful material for the body. Kepler was even accused, his assistant, for the crime because of jealousy. That's all about Brahe's life. Now let's proceed to his contributions and his works.
Mural quadrant. A 2-meter-long brass semicircle mounted on the wall that he used to measure the declination of the stars. Brahe also invented his own versions of the wooden quadrant and the framed sextant. Brahe's observation and observatory. First, conducted astronomical observations without a telescope. Second, built his own observatory named Uraniberg Urania on an island given to him by the King of Denmark. Brahe's Tychonic system. First, proposed the Tychonic system, which combined aspects of Ptolemy and Copernicus models. Second, believed that the 5 planets orbited the sun, while the moon, sun, and stars orbited the earth. Interesting facts about Brahe. First, wore a metal prosthetic nose. Second, kept a pet elk and even got it drunk at parties. Third, hoarded his research data. Fourth, died of a bladder infection from holding in urine too long during a royal banquet. Fifth, his wealth accounted for approximately 1% of Denmark's total wealth.
So, in this part, we are going to introduce Johannes Kepler. So, sino nga ba si Johannes Kepler? So, si Johannes Kepler was born on 1571 in Wilderstadt, Württemberg in the Holy Roman Empire. He is a German nationality. And also, alam nyo ba na si Johannes Kepler, as a child, Kepler contracted smallpox, which caused him to have a poor vision. And at the age of 6, Johannes had to drop out of school so to earn money for the family because ang pamilya ni Johannes ay mahirap, so kailangan niya magtrabaho. He worked in and in the same year, kinuha siya ng mama niya to took him out at night to show him the Great Comet of 1577, which aroused his lifelong interest in science and astronomy. So even though Johannes Kepler have a poor eyesight by age 6, he was extremely fascinated by the night skies. So later on, around age of 9, si Kepler observed the Great Comet. Kung yung sinabi ko nga kanina, yung kinuha siya ng mama niya para ipakita sa kanya yung Great Comet of 1577 and the lunar eclipse of 1580. So, saan nga ba nag-aral si Johannes Kepler nung college siya or anong yun yung pinag-aralan niya? So, Johannes Kepler earned a scholarship to the University of Tübingen to study to Lutheran ministry. And also, it introduced to the ideas of Copernicus while at the university and was fascinated by them. So, habang nag-aaral siya doon, na-introduce sa kanya yung ideas of Copernicus. So, in 1956, while a mathematician teacher in Graz, sumulat siya ng the first defense of the Copernican system. At tinawag niya itong Mysterium Cosmographicum. So, and also, Johannes Kepler studied the theories of the Polish astronomer Nicholas Copernicus, who proposed the heliocentric model of the solar system.
So mas more on nag-focus nga siya sa astronomy, which yung nabanggit ko kanina na mas pinag-aralan niya yung theories nung Polish astronomer na si Nicholas Copernicus na nag-introduce ng heliocentric model of solar system. And then, alam niyo ba na si Johannes Kepler, nag-join siya kay Tycho Brahe. So, Johannes Kepler worked as an assistant ni Tycho Brahe, which is binigyan siya ng primary task in Prague is to investigate the orbit of Mars. So, yun lang yun. And alam nyo ba na si Johannes Kepler involved, or let's say na si Johannes Kepler ay sinasabi nila involved daw siya sa pagkamatay ni Tycho Brahe, which is, here are the facts or yung details kung involved ba talaga siya or hindi. It suggested that Tycho Brahe's cousin or an accident could be responsible. So that means hindi talaga siya responsible sa pagkamatay ni Tycho Brahe, which is until now there is unclear evidence or wala pa talagang solid evidence na pwedeng na sabihin natin na involved talaga siya sa pagkamatay ni Tycho Brahe. So Johannes Kepler died in November 15, 1630 in Regensburg, where he was collecting in the city to collect money related to the Rodolphine tables. The Rodolphine table or the Latin tabulae Rodolphinae, yun ay nagko-consist of a star catalog and planetary tables na yun nga na si Johannes Kepler ang nag-publish. So, Kepler was buried in a local church, but the church was later destroyed during the 30 Years' War, and his tomb is now lost.
Alright, thank you for that, Reporter Ledesma. Now we will proceed to Kepler's works.
In his major astronomical work, Mysterium Cosmographicum, the Cosmographic Mystery, published in 1596. These books explain Kepler's cosmological theory based on the Copernican system, in which the 5 Platonic solids dictates the structures of the universe. It is speculated that the orbits of the 6 planets known at the time, Mercury, Venus, Earth, Mars, Jupiter, and Saturn, could be arranged in the sphere nested around the Platonic solid. The diagram shows the idea of Johannes Kepler's the Platonic solid from the Kepler's Mysterium Cosmographicum. He has his own idea of how the universe might be ordered. Like Copernicus, he believed that the sun would be the center of the cosmos. However, he thought that he could determine the arrangement of orbital spheroids and location of the planets by nesting the so-called Platonic solid. These are the solids that all have equal sides. Now, he didn't seriously believe that there were geometric objects in space, but rather than arrangement of this geometric object would reveal the location of the planet orbits. But lacking the idea, he had no way to test this until Tycho Brahe. He came a calling for Kepler, went to work for Tycho, but the problem was that he could not get all of Tycho's data. You see, Tycho was a little bit insecure and he didn't want to just give this young mathematician all his data, so Kepler worked with what little scrap of data Tycho would pass along. When luckily for Kepler, Tycho died, and now Kepler had the opportunity to finally test his idea to see if it was correct, but it wasn't. In fact, he could not get the planet to fit in perfectly circular orbits that his model required. The data just would not agree with his beliefs, and so he discarded his belief. And he came out with the law of planetary motion, and it's this so-called Keplerian law. Kepler's first law, the law of ellipses. It means that the planet move around the Sun in elliptical orbits. An ellipse is a closed plane curve that resembles a stretched-out circle. Note that the Sun is not at the center of the ellipse, but at the one of its foci. The other focal point has no physical significance for the orbits. The center of an ellipse is the midpoint of the line segment joining its focal points.
Kepler's second law of planetary motion, the law of equal areas. It states that the line joining the Sun and the planets sweeps equal areas in an equal interval of time. Imagine a line appearing from the Sun and joining planet. This is called the radius vector. Now, let's assume this planet moves from position 1 to position 2 in an equal interval of time. And along with the position of the planet, the position of radius vector has also changed and its movement has covered a certain area, as well as which we call as area 1. Now let's move this planet to the opposite side where it travels from position 3 to position 4 in the same amount of time denoted by the alphabet P, which we will call the area 2. Now, according to Kepler's second law, area 1 will be equal to area 2. Next is the third law, which is called the law of harmony. As we know, a planet denoted by the alphabet P takes one revolution around the Sun in T time, also called the time period. It states that the time period of revolution of a planet in its orbit is directly proportional to the cube of 7 major axes of the elliptical path around the Sun. It explains how long a planet takes to finish one revolution depending on its position from the Sun. Meaning, as the planet's distance from the Sun increases, the time they take to orbit the Sun also increases.
Now that we know about Kepler's and Brahe's works and life, now we will be discussing what is the connection between the two, what are their similarities. First is the collaboration. Now from our discussion, we have mentioned that Kepler was assistant to Brahe. So Kepler used Brahe's research data for his planetary motions and laws. Now speaking about planetary motion, both of them have contributes to our understanding of our planetary motion. Next is heliocentrism. So both of them believe that the center of our solar system is the Sun, even though Brahe's model was the hybrid geoheliocentric system, which was later popularized by astronomers like Copernicus and Galileo. Last but not the least is their influence on modern astronomy. So both of their work laid the foundation for our understanding of modern astronomy and the celestial mechanics. Now that's all about our Kepler's and Brahe's report. Thank you for listening.